Okay, today we're looking at a rhombus and a square. First thing we'll look at is the rhombus. It's a quadrilateral with all four sides congruent. So if we have a picture of a rhombus here, they're all congruent. If a parallelogram is a rhombus, then its diagonals are perpendicular, which means if we draw the diagonals, they will form right angles. Okay, the other thing, each diagonal bisects, which means splits in half, a pair of opposite angles. And in this case, that means that this angle is congruent to this angle because the diagonal bisected the entire angle in half. This angle is congruent to this angle. Now on the opposite side of it, these angles are congruent to each other. Okay, so diagonals are perpendicular, diagonals bisect each pair or pair of opposite angles. Now, the test to prove whether or not it's a rhombus, we can look at right here. If the diagonals, I'm just going to draw a parallelogram. If a parallelogram are perpendicular, then the parallelogram is a rhombus. So if we can prove that the diagonals are perpendicular, which we can do that by finding the slope of the diagonals, and if they're opposite reciprocals, then they're perpendicular, and the figure is a rhombus. Another way, if one diagonal of a parallelogram bisects a pair of opposite angles. So if one diagonal bisects a pair of opposite angles, which we looked at the diagram above, if we have a scenario where we see this, they're congruent, then yes, it's a rhombus. And the last one, if one pair of consecutive sides of a parallelogram are congruent. And what that means is if we have a figure and I tell you that that side's congruent to that side and it's a parallelogram, then it's a rhombus. Because remember, in a parallelogram, opposite sides are congruent, which would then mean that all four sides are congruent. It's a rhombus. Now with the square, well, we haven't really talked about it, but if a quadrilateral is a rectangle, and the way we prove a rectangle, if it's a parallelogram, the diagonals are congruent. So if the diagonals are congruent, and it's also a rhombus, which means the diagonals are perpendicular, then it's a square. So if we can prove, so we check to see if it's a rectangle by checking to see if the diagonals are congruent. Then we check to see if it's a rhombus by checking to see if the diagonals are perpendicular. And if it meets both, then it's a square. If it only meets one, if it's a rhombus, then it's possible that it's not a square or a rectangle. And if it's not a rectangle, it can't be a square. It gets a little confusing, but we'll look at some examples here in a minute. Okay, so diagonal of a rhombus, WXYZ intersects at point V. If WZX, which is this angle right here, is 39.5, what's ZYX? ZYX is this angle right here. Well, you'll notice that if it's a parallelogram, those angles are supplementary. They add up to 180. The problem is we don't know what this angle is. But since it's a rhombus, we know that the diagonal bisects it, so this angle, these two are actually congruent. So while that one's 39.5, that one's also 39.5, and if we add that together, we get 79. Now that angle plus that angle equals 180. So to find out what that x is, what that angle is, the one we're looking for, we subtract 79, and we get x equals 101. That's the measure of angle ZYX. Okay, and the other section, other part of this question says, let me erase this. It says that WX is 8x minus 5. WZ is 6x plus 3. Now, how do I solve for x? Well, it's a rhombus, which means all sides are congruent. So I could just set those equal to each other and say 8x minus 5 equals 6x plus 3. Subtract 6x, add 5, divide by 2, and x equals 4. And that would be your answer. Okay, and the last question in our notes, get rid of that. Hector is measuring the boundary of a new garden. He wants the garden to be square. He has set each of the corner stakes 6 feet apart. What does Hector need to know to make sure the garden is square? Well, first of all, if he's got all the sides lengths congruent, he's got to make sure that his diagonals are congruent. If his diagonals are congruent, it's going to be a rectangle, it's going to be a square. That means it's going to have 90-degree angles. If they're not congruent, then we would not have 90-degree angles, and it would not be a rectangle, it would be a rhombus. Alright, looking at your assignment, you should be okay on the first section, 1 through 12, or 7 through 12. Let's look at number 19 together. The first thing I would recommend you do is just draw a picture of a quadrilateral. We'll label it J, K, L, and M. Now we're determining whether it's a rectangle, square, or a rhombus. So we're going to run it through the two tests. Remember, a rhombus, we're going to test to see if the diagonals are perpendicular. To do that, we're going to find the slope of JL and KM. If they're opposite reciprocals, then they're perpendicular, it's a rhombus. So let's look at JL. You'll recall the slope formula is y2 minus y1 over x2 minus x1. So JL will say 3 minus negative 1 over 4 minus negative 4, which would become 4 over 8, 1/2. KM, we would say, now we're looking at KM, we'll say 3 minus negative 1 over negative 1 minus 1. That ends up being 4 over negative 2. That slope is negative 2. Notice these two slopes. They are opposite signs and they are reciprocals. That reciprocal of 1/2 is 2. So yes, they are perpendicular. So I would say, as my answer, diagonals are perpendicular. It is definitely a rhombus. Now, next part, we have to check to see if it is a rectangle. You recall for rectangle, we use the distance formula. Distance formula is x2 minus x1 squared plus y2 minus y1 squared. So we're going to find the distance of JL. So JL, we have 4 minus negative 4 squared plus 3 minus negative 1 squared. We end up with 8 squared plus 4 squared, which is 64 plus 16, or square root of 80. So that's the distance of JL. Now we need to find the distance of KM. Km, that would be negative 1 minus 1 squared plus 3 minus negative 1 squared. And when I get negative 2 squared and I add it to 4 squared, that ends up giving me 4 plus 16, which is radical 20. Now there's the distance of that diagonal. Notice these two diagonals, they're not congruent. So I would say the diagonals are not congruent. Therefore, it is not a rectangle. And remember, it's a square if it's both a rhombus and a rectangle. So not only is it not a rectangle, but since it's not a rectangle, it's not a square. And that would be my answer. Okay? That was all number 20, number 19. Number 21, you're on your own. Let you try that one out. The rest of the assignment I think you'll be okay with.